All right, this is the key to graphing linear equations. This is part A in section 10.2. All right, now remember these are linear equations, so when you graph linear equations, you'll be graphing lines. And when you're graphing linear equations, you're graphing the solutions. So basically what you're going to be doing is finding solutions to these equations. Notice that these equations have two variables x and y, so hence you're going to see that in our discussion in lessons that there are an infinite number of solutions. So you can't list them because they're an infinite number, so we're going to graph the solutions instead and then graph our line. All right, so we want to use a t-table. Keep that in mind. So read the directions carefully. So use a t-table. You want to label the points, and you want to plot at least 3 points. Now remember, to graph a line, you just need 2 points. But use 3 just in case one of your points is incorrect. So therefore, you can easily determine if your points lie in the same line, because they're supposed to lie in the same line. They're supposed to be collinear. So one of the things you may want to do is use a t-table. Make sure it's an ordered pair. Put x in the first column, y in the second column. And whenever y is by itself, see how these two y's are by themselves? That's the easy kind to use a t-table with. So when y is by itself, you're going to let x be some values. It does not matter what you let x be. Now as you go through this, just make sure you use x values that will fit, the point will fit somewhere in this coordinate plane. So you don't want to extend it. If the point's here, just do another point. If the point's somewhere around here, do another point. So just make sure it fits within this plane. All right, so one of the values you want to use for x is 0. So always try using 0 for x. So if x is 0, where we see the variable x, you're going to plug in 0. So I'm going to go down here. I'm going to get y equal negative 3 times 0 plus 2. And so negative 3 times 0 is 0. We use the order of operations. You're going to multiply before you add. So you get 0 plus 2, which is 2. All right, so I have the point 0, 2. So I'm going to plot the point 0, 2, which is here. And I'm going to label it. So that's a point 0, 2. All right, now we're going to pick another point for x. I'm just going to go ahead and pick, let's say, the value 2. So if x is 2, where we see the variable x, I'm going to substitute 2. So I'm going to get y equal negative 3 times 2 plus 2. Now when you remember, you multiply before you add. We're using the order of operations. So negative 3 times 2 is a negative 6. Negative 6 plus 2 is a negative 4. So I'm going to plot the point 2, negative 4. I'm going to apply the ordered pair to negative 4. So 2, negative 4 is right here. Now all you really need are 2 points. All right, but the direction says use 3 just in case one of these points is incorrect. So if you made a mistake here and you say the point should be here, then that's a different line than what this looks like. All right, so remember, what we're doing now is we're labeling solutions. So these are all solutions. So far I found 2 solutions to this equation. So when x is 0 and y is 2, the left side is going to equal the right side. When x is 2 and y is negative 4, the left side will equal the right side. So you're finding solutions. Now I just want you to find one more solution. So let's go ahead and use a negative number. So if x is negative 1, I get y equals negative 3 times negative 1 plus 2. And then negative 3 times the negative 1 is a positive 3. 3 plus 2 is 5. So I'm going to plot the point negative 1, 5. So I found another solution. So I get negative 1, 5, which is here. So I'm going to label the point negative 1, 5. And then so far I've found 3 solutions. That's all I really needed. And then I'm going to draw my line. Now when you're drawing your line, keep in mind you are indicating what the solutions are to this equation. So every point on this line I just drew, every point here is a solution to that equation right here. This point right here that I'm pointing to, that's not a solution. This is not a solution. This is not a solution. Only these are solutions to that equation. Now don't forget to draw your arrow. And so that's what we have. Okay, now before we go on, just like we did in one of the lessons, let's see y. See this point here, which is 4, let's say 5. I'm just choose 4, 5. See this point right here, 4, 5? Let's see why that's not a solution. It's not on this line. So if I go back over here, remember I want to ask, is 4, 5 a solution? And let's see why it's not on this line. Well, remember this is x, this is y. So where we see the variable y, you're going to plug in 5. Where we see the variable x, you plug in 4. So I get 5 equal negative 3 times x, x is 4, plus 2. Negative 3 times 4 is a negative 12. Negative 12 plus 2 is a negative 10. And notice those two are not equal to each other. So that's why it's not a solution. So remember, you're only graphing, you're only plotting points that are solutions to this equation. And that's what these are. So there's an infinite number of points on this line. See, I've listed 3. There's no way you can list all of them. They're an infinite number. So you graph it instead. All right, now here we have a fraction. So let's remember what to do when we have fractions for the coefficient of x. Now, you may remember in a previous course there's something called the slope-intercept form. But remember, read the directions. I want you to use a t-table because we're going to need that idea of using a t-table later on. So let's practice using a t-table with this instead. All right, so make sure you follow directions. So whenever the coefficient of x is a fraction, use values of x that are divisible by this denominator. So a value of x that's divisible by 2 is 0. And then think of, since 2 is an even number, think of even numbers. So let's say 2 is divisible by 2, negative 2 is divisible by 2, 4 is divisible by 2, negative 4 is divisible by 2, and so on. I'm not going to use all these, but that's the idea. Use those numbers. See, if you use another number other than these listed, you're going to end up having to deal with fractions. And then you would have to estimate where this is in here. So make things easier on yourself. Use values of x that are divisible by this denominator. So if x is 0, I get y equals 1/2 times 0 minus 3. Well, 1/2 times 0 is 0. 0 subtract 3 is a negative 3. So I'm going to plot the ordered pair, 0, negative 3. So that's right here. And then remember, you got to label this, so here's 0, negative 3. Then let's try 2. If x is 2, I'm going to get y equal 1/2 times 2, because that's what I'm saying I want x to be this time. And whatever that is, I'm going to subtract 3. Well, half of 2, and remember, some of you may still have some difficulty with fractions, but let's think about what we see here. We have 1/2 times 2. Now, some of you, if you have trouble looking at this the way it's written and determining what to do, rewrite it. Rewrite this. So that means the same thing as 1/2 times 2 divided by 1. So notice this means the same thing as this. And sometimes for some students, this is a little bit easier to deal with than this is. Now, one of the things you learned in the previous course was to reduce, if possible, and then multiply your numerators and then multiply the denominators. Or you can multiply first and then reduce. But I'm going to go ahead and reduce first. So 2 into 2 is 1, 2 into 2 is 1. Now remember, when I was using values of x, I was using values of x that were divisible by 2. So the whole point here, when you're using these values of x that I'm indicating here, you want to reduce. This will always be a 1 right here. This factor will always be a 1. 2 divided into 2 gives me a factor 1. 2 divided into 2 gives me a factor 1. So this right here is always going to be a 1. That was the whole point of using values of x that were divisible by 2. Now let's go ahead and multiply. 1 times 1 is 1. 1 times 1 is 1. So I multiply the numerators, you multiply the denominators. And 1 divided by 1 is 1. So I get the point 2. Oh, I'm sorry, I forgot. Oops. Right here. So that's 1. 1 minus 3 is negative 2. So that's negative 2, excuse me. I forgot to go back. So make sure you go back. All right, so 1/2 of 2 is 1. And 1 subtract 3 is negative 2. So I get the point 2, negative 2. See, if I had to put a 1 there and I go into the next one, and I had done that correctly, they would not have been collinear. All right, so I'm going to apply the point 2, negative 2, which is here. So there's 2, negative 2, and we'll go ahead and put that right here. 2, negative 2. All right, let's try negative 2. So if x is negative 2, I get y equals 1/2 times negative 2 minus 3. All right, let's go off to the side and kind of deal with half of negative 2. So some of you right away can determine what half of negative 2 is. That's fine. If you're having difficulty with fractions, go off and rewrite it, just like this. If you're having trouble reading the way this looks, write it as this, 1/2 times negative 2 over 1. And then we're going to use the same idea we did here. So the whole purpose of using values of x divisible by 2 is that this right here had better be a factor 1. 2 into 2 is 1. 2 into negative 2 is negative 1. And so I get 1 times negative 1 is a negative 1. 1 times 1 is 1. So I get negative 1 over 1, which is negative 1. So remember, a positive times a negative is a negative. So I get negative 1 here. But that's what this is right here. So negative 1 subtract 3, which means the same thing as negative 1 and a negative 3 is a negative 4. So that goes here. So I plot the point negative 2, negative 4, which is right here. So negative 2, negative 4. And then I draw my line. And remember, what you've done was you've listed 3 solutions to this equation, but you want to graph the line, which indicates you want to graph all of the solutions. So here's all of my solutions. Anything that's, and I didn't draw this very well, but anything on this line is going to be a solution. So that's what you just found. You found the solutions to this equation, and there are an infinite number of solutions. All right, number 3. So number 3, we have a fraction also for the coefficient of x. Y is by itself. That's the easy kind whenever y is by itself. So we can use a t-table. And a nice number to use for x is always 0. So let's use 0 for x. And so if x is 0, I get y equals negative 2/3 times 0 plus 1. And then using the order of operations, negative 2/3 times 0 is 0, and 0 plus 1 is 1. So I get the point 0, 1. So I'm going to plot that point 0, 1, which is right here. It's on the positive y-axis. Label it. Now let's now remember, you want to use values of x now that are divisible by 3. Use multiples of 3. So 3, negative 3, 6, negative 6. So those are all multiples of 3. 9, negative 9, 12, negative 12, and so on. Okay. All right, let's use 3 now. So if x is 3, I get y equals negative 2/3 times 3 plus 1. Now we got to figure out what this part is right here. That right there. So we go off to the side. Let's kind of figure this thing out. Negative 2/3 times, and again, you may want to rewrite this 3 that I have in parentheses as 3 divided by 1 and then reduce. So remember, the whole purpose of using values of x that are divisible by this denominator is so that when you reduce, this becomes a 1. And it does. 3 into 3 is 1. 3 into 3 is 1. And then, remember, you multiply the numerators. Negative 2 times 1 is a negative 2. And then multiply the denominators. 1 times 1 is 1, which gives me negative 2. Now, that's what this is right here. So negative 2 plus 1, it gives me a negative 1. So I'm going to plot the ordered pair, 3, negative 1, which is here. All right, now let's try negative 3. I'm going to do this right here. So if x is negative 3, I get y equals negative 2/3 times a negative 3 plus 1. Now let's kind of figure out what this part is right here. So let's do this right here. So negative 2/3 times a negative 3 over 1 divided by 1. Remember, the whole purpose of using multiples of 3 right here is so that when you reduce here, this becomes a 1. 3 into 3 is 1. 3 into negative 3 is negative 1. And remember, a negative times a negative is going to be a positive, so this should be a positive value right here. So that product should be positive. So negative 2 times a negative 1 is a positive 2. And the denominator is a positive 1 times a positive 1 is a positive 1, which gives me 2. So this right here is 2, and 2 plus 1 is 3. So I'm going to plot the point negative 3, 3. Negative 3, 3 is right here. Let's see, 1, 2, 3, 3. And so there's the point negative 3, 3. And so notice that those 3 points, those 3 solutions that I have plotted here are all collinear, so they all lie in the same line. So now I'm gonna graph all of the solutions though, because that's the idea when graphing equations is to graph the solutions, and so there are my solutions. Okay, now number 4. Notice in when we talked about numbers 1, 2, and 3, we said that whenever y is by itself, that's an easy kind to deal with. So here, though, the value of y is not by itself. The variable y is not by itself. But so let's go ahead and get y by itself. Right now, multiplying by 3, the opposite of multiplying by 3 is to divide by 3. So first of all, I'm just going to go ahead and rewrite this over. And then I'm going to divide both sides by 3. Remember the multiplication property of equality. What I do to one side, if I divide one side by a number, I got to do it to the other side as well. Now, 3 divided into 3 is 1. 1 times y is y. So that's the idea you want to do. You want to get y by itself. Now, in a lesson, we talked about the fact that when you see this, you want to make it look like this, where you have two terms. You have this term and you have this term. So to do that, you're going to say negative. See, there are two terms in the numerator. The first term is negative 5x. The second term is a positive 12. And one term in the denominator. So whenever you have that situation, you can write these as separate fractions. So you would say negative 5x divided by 3 plus 12 divided by 3, and then just reduce 12 divided by 3, and if you can, do this as well. So I get y equals negative 5/3 x plus 4. And now this looks very similar to that. Okay, so now we're going to use the t-table. So I'm going to use values of x that are divisible by 3. And remember our discussion earlier, make sure the points you choose fit within this coordinate plane. So let's just do the same things we did earlier. So if x is 0, I'm going to use values of x that are divisible by 3. So 3, negative 3, 6, negative 6, and so on. Okay? All right, let's try 0 first. 0 is always the easy one to use. I'm going to make sure you go here, though, not here. And make sure that your process gives you the correct equation. So this equation better be equivalent to that equation. So if you made an error somewhere, then they're no longer equivalent, and you're graphing the wrong line. Your line that you graph will not be the line for this one. It will be for the line that's here if it's incorrect. So if x is 0, I get y equals negative 5/3 times 0 plus 4. Negative 5/3 times 0, 0. 0 plus 4 is 4. So I plot the point 0, 4. So 0, 4 is here. If x is 3, I get y equals negative 5/3 times 3 plus 4. Now let's go off to the side if you need to and figure out what this part is. So negative 5/3 times 3 divided by 1. Let's reduce. 3 into 3 is 1. 3 into 3 is 1. And so negative 5 times 1 is negative 5. 1 times 1 is 1. So I get negative 5. So this becomes negative 5 plus 4, which is negative 1. So when I go to my coordinate plane, that ordered pair does fit in here. So far we're okay. So 3, negative 1 is here. Make sure you label. So that's 0, 4. That is 3, negative 1. All right, let's try negative 3. So if x is negative 3, I get y equals negative 5/3 times negative 3 plus 4. All right, let's kind of figure out what this part is. So I'm going to go right here. So that's going to be negative 5/3 times negative 3. That's times negative 3 over 1. And so 3 into 3 is 1. 3 into negative 3 is negative 1. A negative 5 times a negative 1 is a positive 5. 1 times 1 is 1, which gives me 5. So this right here is 5, and 5 plus 4 is 9. But when I try and plot that point, negative 3, 9, see, I would have to extend it. So negative 3, 9 is up here. So let's do a different point instead. Use points that are within the plane that's given. Try not to extend it if you are not, if you don't have to. So let's try 6 instead. Let's see if 6 is going to help. So I get y equal negative 5/3 times 6 plus 4. All right, so let's go ahead and kind of deal with that. So negative 5/3 times 6 over 1. 3 into 3 is 1. 3 into 6 is 2. So I get negative 5 times 2 is a negative 10. 1 times 1 is 1. So I get negative 10. So this becomes negative 10 plus 4, which is negative 6. So I get the point 6, negative 6, 6, negative 6, and it does fit. So that's going to be right here. So that's 6, negative 6. And so then, remember, I've plotted three solutions. I found 4, but I'm going to use 3 of them. And I'm going to graph the rest of them. So here are the rest of the solutions to this equation, which is a line. Don't forget to draw your arrows. Make sure your points are labeled because the direction's set to label them, and you're done. So this is the key to the worksheet dealing with graphing linear equations.